Action. Hello and welcome back to Stats1. So this is section 4.4. We are continuing our exploration of probability, and now we're going to take a look what happens when we have multiple variables. We're going to use contingency tables and then take a look at joint and marginal probabilities. So they give an example in a book, so we can use that example to explain the concept. This is a table with frequencies, so table of frequencies, and then we can calculate probabilities looking at the table. Now this table is going to be called contingency table. So let's first draw the table. We'll need 7 rows. Great, I have 5. And now I'll do the same thing what they do over there, which is go like this. Because there is nothing that we need over here, so it's empty. And then I need 5 of these. So let's go 1, 2. No, I missed it. I'm supposed to do 3. There we go. So now we have 2 variables. We'll have a variable age and we'll have a variable rank. And this table will contain the ages of and rank of professors. You have the 4 ranks. There is the instructor, assistant professor, associate professor, and full professor. There's more, but let's say that's it. And then we have ages under 30, and then so on. So ages is less than 30, then 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. Actually, wait. No, just over 70, over 60. So larger than 60. And then we have a total. On the last one is also total. So the data goes in the middle, in this bold part of the chart. We have full professor, we have associate professor, we have assistant professor, and then we have instructor. So those are the ranks. And the numbers are 2, 3, 57, 6. The total 68. Then we have 52, 170, 163, 17 for a total of 402. We have 156, 125, 61, 6 for a total of 348. 145, 68, 36, and 4, for the total of 253. And then we have 75, 15, 30 for the total of 93. The totals of the totals in the last column, sorry, last row, so totals of each column are 430, 381, 320, 33, and total amount of all professors together is 1,164. So that's the grand total cell. So a table like this will be called contingency table. And you see there are two variables that we are showing here. One is the number of professors, and then we put them all in the rank of professors, and then we put them, categorize them by age. So this is what we have now as data. And these are all frequencies. So we know that there are 125 associate professors that are 40 to 49 years old. So you can read the chart. You can just read the data, right? So let's say there are 125 associate professors who are in 40s. So the table shows the frequencies of all ages and all ranks for these professors. Now you can go to a company and you can put, accountants, lawyers, workers, maintenance people, right, and then break by ages and so on. You can do whatever, and there are many other examples that we are going to explore. So in this contingency table, we can now look for what we call the joint and marginal probabilities. So we are going to, I'm hoping that you guys are going to use language. Let me just check something real quick. To understand the locations in this, and then talk about joint and marginal probabilities. So for instance, first of all, this column here is called the margin, and this one is also called margin. The total, yeah, the row and the column, the total row and column are called margins. And you have the cells in the middle are cells where the data is. Okay, so now I can wonder about different probabilities, and the type of a question will decide whether it's marginal probability or joint probability. So now I'm going to actually give you formulas. I don't think that book actually gives these formulas anywhere. They explain these formulas in the text, but they do not actually give you the formula to calculate any of these things. So I'm going to define through like a formula. So joint probability which is going to be the probability of AI and BJ. Now, these are the two different events, okay? We have age event, actually I can call it, whatever, event A and event B, all right? So event A is age in this case, and event B is rank. Now, what are the little I and J? Well, I is just location somewhere in here, and J is a location in terms of it's like a row and columns, just to find the spot. So if I have A1 and B1, A1, B1, well, that's going to be here, because that's 1, 1 location. Right, so you can locate any cell by using this. So now what is the probability of that? The probability of the joint probability is going to be the frequency in AI and BJ divided by grand total. So I can calculate the probability of any of these inner cells as 2 divided by 1,164, 3 divided by 1,164, 57 divided, and that would be the joint probability. Now, marginal probability would be the probability of, I see why it's very difficult to write it as a formula, because now you are dividing a number from the margin with the grand total. So I'll just say probability margin is equal to the total divided by grand total. It's a very vague formula, but when I give examples, it should make sense immediately. So let's calculate some probabilities. Let's do 5,000 examples here so everything is clear.
I get the A1, but where would BJ be? Like, how do you...
Well, see, A1.
Right, exactly.
A1 is going to be, so this age is A, right?
Yeah.
So you have all of the A values here.
Uh-huh.
So we can switch them, it doesn't matter. So A1, so this is event A, and this is event A, and this is A. So A1 is here.
Yes.
All of these are A1.
Right.
And all of these are BJ, B1.
Okay.
All right? So you see that this is B1, B2,
Okay.
B3, right? So each row has its own location. It's actually not important to label them as A and B at all, because if I ask you for, well, this is the question now. What is the probability of picking let's say instructor in 30s? You see that? This, just saying instructor in 30s, you immediately zoom into the cell, because there is only one cell. So this is why this AI and BJ, they don't matter at all. It's just for us to kind of, okay, there is a location somewhere, right? So we have instructor in 30s. You zoom in immediately on 17. Very good, because that's instructor in 30s. So you will go there, and you would say, all right, so probability of instructor and 30s, right? So that's the probability of instructor and 30s, is going to be 17 divided by 1164. And then you compute that, right? So 1164. that should be 0.015. So it's about 1.5%. So about 1.5% of all professors and instructors at this place, 1.5% of them are rank instructors in 30s. Next question. What is the probability that we have the associate professor in, let's say, 40s? You will go and you will look for associate professor in 40s. So, probability, associate in 40s. Well, associate and you have to have both. So now, associate in 40s. Associate in 40s, that's, oh, that was a question I asked earlier. So that's 125 divided by 1164. 125 divided by 1164, and that is what? 0.107. So that's about 10.7% of everyone are associate professors in 40s. Let's go another one. I'll ask you to do this. So probability of assistant professor in, let's go with 50s. Doesn't matter. Right? So assistant professor in 50s. So assistant professor in 50s, 3.1%, right? So what are the numbers? 36 over 1164, which is 0.031. So that's about 3.1%. Now, this is what we have. So if all of these 1,164 people go in one room, and you have no clue who's who, right? You pick a person at random, there's 3.1% that person is assistant professor in 50s. Now, obviously, right, by age, you can tell if someone is in, right, let's say in 60s and 30s. So you would have to be blindfolded to pick a person, because you can, right, you can skew your, but you can't guess ranks pretty much. Even though, yeah, the older the person is, chances are, as you can see from the data, right, chances are that the person will go higher. Look at the instructor, right, 0 instructors in over 60, only 3 assistant professors, 15 associate professors, and then 75 right, full professors. So the chances are that, you know, most of the full professors will be in the older, which is, I mean, it's true for every single one, but when you compare, you know, row by row, you see also that. And then you also see that the least amount of full professors are in their 30s. Good. So those would be joint probabilities. You go to particular cell and you divide that by grand total. Now, you see the word and. So you want the person to be instructor and you want the person to be in 40s, right? So that's instructor and 40. Now, the new type of question is going to be, what is the probability of an instructor, right? So that the person you pick is an instructor. Let me actually write that as a question first. So, probability that the chosen person is an instructor. Well, that will be probability of instructor. Now you have to go and say, what is the total amount of instructors? You see, I'm not restricting the age now. I want to know all. So that's the reason why I'm going to look at the total number of instructors. And if I look at the total number of instructors as 33 divided by the grand total. So 33 divided by 1164 is going to give me 0.028, or about 2.8%. So this is the amount of instructors at this college, university, whatever it is, right? So you have full professors, you have associate professors, assistant professors, and you have instructors. So these instructors are the 2.8%. I can also ask, what is the probability that the person chosen, right? Probability that the chosen person is in 40s. So see, now I want the probability of 40s. You have to go in the total for all 40s. Total of all 40s is here. 348. That's all of the 40s. So 348 divided by 1164, and that's going to give you 0.299. So you can say 30% if you want, or 29.9%. So about 30% of all professors and instructors of everyone, right, on this table is in 40s. So this is what we call contingency table, and believe it or not, lecture is over. There is nothing else in this lecture. The name of the table that you see is called the contingency table. It gives you two variables. In this case, you have the age and you have the rank. And then we are talking about two different types of probabilities that we compute. One probability is called the joint probability. See, words, guys, joint probability. You are joining both variables, which is why you are zooming in on a particular cell. You want someone to be in 40s, and you want that person to be a full professor. So it's joint. What are we joining? Joining 40s and joining full professor. So joint probability, that divided by the grand total. The second type of probability is the marginal probability. Again, it comes from the margin. So all of the assistant professors, well, that's going to be 320 divided by the grand total. Or all people older than 60, great, 93 divided by. So marginal probability is going to be a margin divided by the grand total, and the joint probability is a cell, particular cell, right, which the text will tell you which one to zoom in, zoom onto, right? So it's a cell divided by the probability. And that's the lecture.
So in the exam, did you ask the question about margin? What is the marginal probability?
No, I just asked what is the probability that a person is in 30s.
Okay.
That's it, because that's the marginal, right? Because all of these people are in 30s.
Right.
So you have to take the total of 30s divided by this. What is the probability that someone is a full professor? What's the probability that someone is a full professor? 430 divided by 11. Now, what is the probability that someone is a full professor and in 30s? 52 divided by 1, right? Because see, I'm asking, what's the probability of full professor? And I stop. Oh, this is only one category, right? Full professor. Well, this is all full professors. But I say full professor and in 30s, well, that limits you here immediately.
Will we ever see a problem that's like, what is the probability that they're a full professor or in their 30s? And have to like do that.
Well, that's
like the deck of cards like red and or king, where you had to subtract the 2 red kings.
yes, but you don't need to do contingency table for that, right? I mean, you pick out the numbers from the table. So yes.
So when you think about it, like joint, think about 2 and marginal, think about 1. Like one thing that you're picking.
Yeah, joint. You have to have 2 things because if something is joint, you better write filing taxes jointly. Well, that has to be 2 people, right? Or filing single, 1, right? So marginal probability is always one number in the margin, one total, right? For whatever quality you're looking at, and then joint, you need to have 2 to zoom into the particular cell.
So these tables are on the top, or will you be getting the tables filled out, or are we going to be responsible?
We will talk about that. What I like to do for exams is give you partial table. So I do this. Something like that. So you have some Sudoku to do first, right? And then you get to answer questions. So
Very simply, to add up the 2, the 57, and the 6, and subtract it from the 68, and that will give you your missing number.
right? So you add all of these, and what's missing to get to 68 goes there. And then you say, okay, add this, 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 and this to get this, then you can get that one.
Right.
Across, add to get that one, across, add, right? So stuff is missing. But play Sudoku, right? Play Sudoku a little bit. It's just except you don't have to add. I mean, this is the next level, okay? You what?
I never played Sudoku.
Well, this is the great time. This is the great time to. Trying to see. There they are. All right, so you can start practicing here, and then by the time you get the contingency table, nothing to worry about.
Oh, that's awesome.
I know. Yeah, look at that. The regular Sudoku is just this one, right? Yeah, what you would find in newspaper, right? Little puzzle point, so that's it. Right? You have a 9x9 grid. You know, just a little bit. Don't worry about it. Practice a little bit. It takes. This is not what I play all the time. I play 2048 when I. You play 2048?
I don't know what that is.
You don't know what 2048?
On your phone.
Never heard
Yeah,
of
it's
it.
a great game.
Yeah,
Great game.
this thing.
Okay, so what do you do there?
You add. So you add like this, and you have to get to 2048. I'm just moving these blocks on top. See? Now 4 plus 8 and 16. See? And you keep adding, trying to make.
So you can only combine numbers that are the same.
They're same numbers add, yes. So the same number 8. I can see how they add. So now 4 and 4 will make 8. Now, if I move to the left, if I swipe left, 16 plus 16 gives 32, and 8 plus 8 gives 16. 2 plus 2 in the top gives you this. See? It goes like this. And then you... But...
This is one I will not.
No, but...